Hello, grade 9. Are you fine? Today we are going to learn about the chemical bonding. This is the chapter 3. An atom is the smallest unit of matter which is invisible. This is the atom of helium. Electrons are placed in shells according to rules. The first shell can hold up to 2 electrons, and each shell thereafter can hold up to 8 electrons. Electron shells. Atomic number is the number of electrons. Electrons vary in the amount of energy they possess, and they occur at certain energy levels of electron shells. Electron shells determine how an atom behaves when it encounters other atoms. Look at these atoms. This is the hydrogen. It has 1 electron and 1 electron shell. For example, carbon. Okay, carbon has 6 electrons and 2 shells. The first having 2 electrons, it holds 2 electrons. The second holds 8 electrons. Must hold 8 electrons, but there are only 4 electrons. For example, nitrogen, 2 shells. The first has 2, and the other has 5 electrons. For oxygen, 6 electrons in the second one. Okay. So that C would like to for octet rule, atoms tend to gain, lose, or share electrons so as to have 8 electrons. For example, C would like to gain 4 electrons and would like to gain 3 electrons. O would like to gain 2 electrons. Why are electrons important? Elements have different electron configuration. Different electron configuration mean different levels of bonding. Look at the different energy levels. For example, phosphorus has three layers, whereas boron has 2. The number of electrons is a little bit different. Draw Lewis dot structure. You may represent the valence electrons from different atoms with the following symbol: this, or this, or this. Okay, hydrogen could be represented like this, or like this, or like this. This is the Lewis dot structure. Always remember atoms are trying to complete their valence shell or their octet, or to have 8 electrons on the outer energy level. 2 will do, but 8 is great. This is the rule. The number of electrons the atom needs is the total number of bonds they can make. For hydrogen, for example, 1, for oxygen 2, fluorine 1, 3, 1, 4 for the others. Electron dot structure. This is the structure of hydrogen, lithium, sodium. For elements of group 1 or column 1, all they have the same symbol structure. The symbol, only the atomic symbol changes, but all they have the same symbol. Okay, and the same for other columns. Look at those of column 18. Helium has 2. It is saturated. Neon complete its octet. Argon. Okay. General rules for drawing Lewis structure. All valence electrons of the atom in Lewis structure must be shown. Generally, each atom needs 8 electrons in its valence shell, except hydrogen needs only 2 electrons and boron needs only 6. Multiple bonds, double and triple bonds, can be formed C, N, O, P, and S. Central atom have the most unpaired electrons. Terminal atoms on the extremities have the fewest unpaired electrons. such as carbon, fluorine, and hydrogen. Learning check. X would be the electron dot formula for Na or K or Al. This is for Na because it exists in group 1. X would be the electron dot formula for 1, 2, 3, 4, 5. This is an element of group 5. Okay. An attempt to fill electron shell. Two major types of bonding. Ionic bonding forms ionic compound. There is transfer of valence electrons. And covalent bonding forms molecules sharing of valence electron. This is our focus this chapter. The ionic bond formed between two ions by the transfer of electron. Formation of ion from metals. Ionic compound result when metals react with non-metals. Metals lose electron to match the number of valence electrons of their nearest noble gas. Positive ion form when the number of electrons are less than the number of protons. Group 1, they are transformed into ion plus 1. Group 2, ion plus 2, and group 3, ion plus 3. Let's take an example, the sodium, which loses 1 electron to become an A plus. Okay. Magnesium loses 2 electrons to become Mg2 plus. Some typical ions with positive charges or cations, and ions from non-metal ions. In ionic compounds, non-metals in 15, 16, and 17 gain electrons from metals. Non-metal add electrons to achieve the octet arrangement. Non-metal ionic charge is -1, -2, or -3. Look at the fluorine, which gains 1 electron to become F-. Okay, the ionic bond between atoms of metals and non-metals with very different electronegativity. A bond formed by transfer of electrons produce charged ion, all stable conductors and have high melting point. Examples: NaCl, CaCl2, and K2O. This is the ionic bond. There is transfer of electron and electrostatic attraction. This is the most important idea, electrostatic attraction. The ionic bond always formed between metal cations and non-metals anions. They oppositely charged ions stick like magnets. Metals positive and non-metals negative. This is the sodium atom, which gives 1 electron to chlorine atom to become sodium chloride. Ionic bond, electron form Na is transferred to Cl. This causes a charge imbalance in each atom. The Na becomes Na plus and Cl, Cl minus. This is the NaCl. Okay. The covalent bond. What is the covalent bond? Occurs between non-metal atoms which need to gain electrons to get stable octet of electrons or filled outer shell. This is the non-metal. Covalent bond formed by the sharing of electrons. Covalent bonding, pairs of electrons are shared between two non-metals atoms to acquire the electron configuration of a noble gas. The atoms form a covalent bond by sharing their valence electrons to get a stable octet of electrons filled valence shell of 8 electrons. Electron dot diagrams of the atoms are combined to show the covalent bond. Covalently bond atom form molecules between non-metallic elements of similar electronegativity formed by sharing electron pair, stable non-ionizing particles. They are not conductors at any state. Example: O2, CO2, C2H6, H2O, etc. Bonds in all the polyatomic ions and diatomic are covalent bonds. Look at the oxygen. This is a dioxygen. Methane, this is the finished Lewis dot structure. Every atom has filled valence shell like this or like this. When carbon is one of atoms, it will always be in the center. Sometimes two atoms are present, so there is no central atom. We will use a method called ANS, available, needed, shared, to help us draw our Lewis dot structure for molecule. This is the end of our lesson. Thank you for joining and goodbye.